diversity in STEM, particularly when we're looking at the areas of computer science and engineering. And so largely STEM is overwhelmingly white. It is dominated by males largely if we ignore the health sciences. And if we look at bachelor's degrees awarded to females in different STEM disciplines, if we look at computer science, engineering, and physics down here, fewer than 25% of bachelor's degrees awarded in this country go to individuals who identify as female. And so all of these things contribute to a need for a program like the Earth Data Science Corps. And then finally, I would just add that these disparities can lead to inequities and underrepresentation in the workforce too. So again, we see that particularly in areas of computer science and engineering and in some of these physical sciences when we begin to disaggregate things. So what is the EDSC? What can we do to solve some of the issues that I tried to address there in that last set of slides? One approach to addressing those four issues is through a program called the Earth Data Science Corps. And at its core, the Earth Data Science Corps is designed to tackle challenging Earth and environmental issues using programmatic and computational solutions. The EDSC contributes to diversity in the STEM workforce, helps build capacity to teach and learn Earth data science, particularly at some of these smaller minority-serving institutions. And then ultimately, our goal is to help train the next generation of Earth data scientists. So if we dig a little bit more down into some of the details about what the program is all about, ultimately, the Earth Data Science Corps is a partnership between the education team here at Earth Lab and now three really partner institutions. It's a 12-week program that we pay undergraduates to take in the summertime. Over the course of the first 2 years of the program, we've worked with 45 total students. Students learn Python and relevant GIS and Earth and environmental science. The program is taught completely online using Zoom and spatial chat. I should point out that when the award and the proposal was initially written, it was intended to be done fully face-to-face, in person, in Boulder. And then COVID happened. And so everything was moved online rather abruptly. So we've learned a lot about teaching and learning in the online space over the course of the last 2 years in the EDSC. It's modeled after our Earth Data Science Bootcamp course, which I hope to have some time to talk more about at the end. One thing I won't talk much more about here today, but I think that is super important, is that one of the main objectives of the Earth Data Science Corps is to allow our faculty mentors, so faculty partners who work at our partner institutions, they get a chance to develop critical Earth data science teaching skills that they can then take back to their home institution. So that's that capacity building piece. All of this is made possible through an NSF award that was originally awarded to Leah Wasser and Jennifer Balch here at Earth Lab. I came in after the award had already been granted to Earth Lab, and have kind of been in charge of overseeing the implementation of the program since I came in a couple of summers ago. Ultimately, this Earth Data Science Corps Award is part of the NSF's Harnessing the Data Revolution program, which is one of their 10 big ideas. So who is the Earth Data Science Corps? So originally we were working with 4 partner institutions. Now we're down to 3 partner institutions, including CU Boulder. So we work with 2 tribal colleges, United Tribes Technical College and Ogallala Lakota College in North and South Dakota, respectively. We also work with students and faculty at Metropolitan State University in Denver. And then we also have a cohort of students here at CU Boulder, led by Earth Lab's own Bill Travis. So thanks, Bill, for all the work that you've done there. Demographically, we are a pretty diverse group. And so we recruit minorities, women, people of color to help add some diversity to that data science pipeline. And so about 2/3 of our respondents identify as female. About 1/3 of our participants come from a tribal community, with another 1/3 collectively identifying as African American, Asian American, or Hispanic American. But we're more than just bar charts. We are a set of smiling faces and humans. If you see yourself in there, tag yourself. I think there's a couple of folks in the audience who might be here. I couldn't resist putting this up because I can't, thank enough the folks who we've had a chance to work with over the last 2 summers, because it really is just an amazing group. And we're looking forward to adding to that cohort when we start up again here in a couple of weeks, again for year 3. So this is the Earth Data Science course right here. What do we do? What does the Earth Data Science course do? Well, like I mentioned a couple of minutes ago, it is a 12-week program. We teach Python, so of course we use zero indexing. So starting in week 0, we work with a group of outreach trainers from the carpentries. So they come in and they teach some fundamental command line steps like bash and shell. They talk a little bit about Git and GitHub and some very fundamental introduction to Python. We come back and kind of reset things, talk about the tools that we'll use throughout the course of the summer, kind of do those one day at a time so as not to overwhelm students. We spend some time talking about fundamental Python operations, so working with variables, working with lists, plotting in Python with matplotlib. When we get down to week 3 or week 4, that's when we really start to introduce the Earth data science content. And so students are working with time series data, looking at applications around the flooding event that took place in Boulder in 2013. Students get to work with different spatial data, so working with raster data and vector data, doing a lot of the tricks and techniques that you might do using ArcMap or ArcGIS, like clipping and cropping shapefiles, but doing it using open source Python. I should mention too that the curriculum that we use here, like I mentioned, is largely based off of our Earth Data Science Bootcamp that we offer through Earth Lab and the Geography Department. And all of those materials are posted on our Earth Data Science website. I'll talk more about that later. After the first 5 weeks or so, which are really kind of instructionally intensive, a lot of time spent in the virtual classroom, we do spend one final week talking about clean and reproducible code and science communication. And then we really turn things over to the students and the faculty, and we give them an opportunity to apply what they've done or apply what they've learned over the course of the workshops to a locally and culturally relevant project. And so for the first 4 or 5 weeks are very workshop and training intensive, and then the last half of the summer is focused on group projects. At the end, students will present. We record those, put them up on Earth Lab and series YouTube channels, and then they also write blogs to get a little bit of practice, doing some of that written science communication. So if we look a little bit at some of the work that students do as a part of the program, a lot of focus on data visualization and plotting. And so students start out by making bar charts of precipitation trends in Boulder. They would go on to work with time series data. So again, around that Boulder flood event that happened in 2013, looking at stream discharge at Boulder Creek. Then we get into some of the spatial applications. So we do a project where students, or I shouldn't call it a project, more of a homework, I guess, where students develop a map of climbing locations around Boulder. So boulders and walls, for those of you who do rock climbing. I think Max Joseph may have had a hand in developing this activity. And then things kind of culminate in another spatial activity where students make a map of the South Ranger zone in Rocky Mountain National Park. And so they're overlaying lots of different layers here, really kind of ties a lot of the things that they've learned over the course of the previous 5 weeks together. And remember, these are folks that in a lot of sense came into the program without having any experience coding. And so they go from 0 to something like this over the course of 5 weeks. And I just am always really impressed with the students' work. And so I appreciate the opportunity to show that off here. Let's see. I didn't have time or space to include a lot of the figures or plots that come out of the student project, but I did find some room to list them here. And so you can see that over the course of the first 2 years, student projects have focused on things from data sovereignty in the context of COVID data on the Pine Ridge Indian Reservation, flooding on tribal lands, working with neon data, looking at emerald ash borers, which is a really neat project. We've had partnerships with the NC Task over the first 2 years. The students from CU work with Bill, Travis, and Imtiaz Rangwala. In the second year, last summer, students came back. We had a group from MSU Denver that looked at air quality trends in Denver. It was a really awesome project, local relevance. We looked at envisioning resilient campuses in a changing climate. So the students from OLC basically like adapted this project here where they were overlaying shape files onto a digital elevation map. They adapted that to their home campuses and were building like similar elevation models of their campus. It's really interesting projects. And then folks from United Tribes looked at methane dynamics in the prairie pothole. If you'd like to read more about these, I would take out your phone and you can use that QR code there. It will link you to Earth Lab's website where we have the blogs and the presentations from years 1 and 2 posted. And so thanks to Elizabeth and Catherine for getting those up in a place where everybody could see them. Okay, I'm gonna switch gears here. I've spent the last 15 minutes or so talking about what kind of the who, what, and why of the Earth Data Science Core. And what I'd like to do now is move into some assessment data. And so how are we assessing growth in learners' Earth Data Science skills as part of their participation in the Earth Data Science Core program? And so I'm really interested in, how does their involvement in this project lead to or contribute to the development of their science and data science communication skills, their self-confidence with different technical and non-technical data science skills, and their science identity and sense of belonging. And so to do that, we give them a series of 5 survey instruments that capture different components of their technical and non-technical data science skills, including Python skills, data science skills more broadly, data science communication. We assess them on what I call their data science practices, and then finally their science identity. We use what's called a post then pre-retrospective approach. Getting into the methodological weeds here a little bit, but bear with me for a second. Rather than doing a traditional pre then post where we ask them a series of questions at the beginning of the summer and then the same set of questions at the end of the summer, we ask them kind of the pre and the post all at once at the end of the summer. And so we ask them first, how confident or how comfortable are you with these different data science skills? They respond, how do they feel currently after they've completed the workshop? And then we ask them to think back to the beginning of the workshop and how confident or comfortable were you then, do you think? And talk a little bit about that. And so we get what's called a retrospective post test when we ask them to, think back to, a retrospective pre-test, I apologize. That's when we ask them to think back to how they felt at the beginning of the summer workshops. It cuts down on things like what we refer to as response shift bias and pretest overestimation. And this approach has been shown in some cases to more accurately detect the effect of an intervention. And so we like this approach for a number of different reasons. And so what I'm going to do now, there's a series of horizontal bar charts that you're going to have to sit through here for the next couple of minutes. So bear with me. But what we've got here are what we would call the raw responses or the raw counts to each one of these surveys. And I've got them organized by survey dimension. We'll start by looking at the survey that captures Python skills. There's 10 items. These are the 5 most difficult for students to answer based on their before responses. So you can see that by and large, folks were not comfortable doing things like importing text files into Python or working with spatial data in Python before they took the workshop. But then after, fast forward 12 weeks, they are moderately to very comfortable doing a lot of these things, okay? Similarly, if you look at the next set of 5 items from the Python skills survey, again, largely uncomfortable with these different data science skills, Python skills prior to taking the workshop, but we see a pretty significant shift in their attitude afterwards. I'm going to go through these pretty quick. Here's the next set of items. This is off the second of 5 surveys, the data science skills. So these aren't necessarily specific to Python, but are more broad data science skills or abilities. You can see again, generally, the movement is from less confident to more confident following instruction. Here's the next set of 5 data science skill items. We looked at data science communication. Maybe the shifts aren't as big here, but again, still moving in the right direction, the direction that we'd like to see. So largely and notice too that this is a different Likert scale. So before we were looking at comfort and confidence, now we're asking them whether or not they agree or disagree with different statements about their ability to communicate in a data science-y kind of way. We asked them about science practices or data science practices. Again, the shifts here, not as large as what we were observing with the Python skills and the data science skills, but still moving in the right direction, which is positive. And then the final set of 5 items is looking at their science identity. And again, we weren't able to move the needle here as much as we were maybe in the other categories. But the fact that we were able to do this at all to make students feel like they were part of a community of scientists, or that they had come to see themselves as a scientist, to be able to have any movement there at all, the fact that we're doing this in a fully online space, we think is noteworthy and something to be excited about. So, okay, I'm gonna talk a little bit about findings. I'm gonna talk about some methods now and then do some more findings, like you would do. And so forgive me if things seem like they're a little all over the place, but I want to talk a little bit about kind of what you could do next to these raw responses. And so we could be a little bit more quantitative in how we are able to demonstrate growth in these different areas. And so traditionally, what folks do is an approach called classical testing theory when we're working with Likert survey instruments. And so imagine that I gave everyone in the room a 25 item Likert survey about your environmental beliefs, okay? And it's a 5-point Likert scale from strongly agree down to strongly disagree. Traditionally, what folks will do is they will assign a number to each one of these response categories. And then they will tally up everybody's responses. So let's say I got responses from all 5 of these folks here. I would tally up all of those responses, give a number to each one of those responses, total up that number, and then I would use these totals to calculate things like population mean, standard deviation, and then do parametric statistic tests with these numerical values that had been assigned to categorical variables. And methodologically, that approach has a few holes in it. Namely, this assumes that the jump from one step to another is going to be linear, and you can't really say that, And when you do things like t-tests and analysis of variance, it assumes that the data that you're using is normally distributed. And you can't say that about data that is ordinal. And so one way around that is through an approach called Rasch measurement or Rasch modeling, which is from a larger family of measurement models called item response theory. In short, Rasch modeling is a way of converting data that lives on an ordinal scale, so like I just showed you there, and converts that to a linear or a ratio scale, and you can use those values then in your parametric tests. And so that's what we're going to do here. Kind of one of the goals of Rasch modeling and item response theory is to develop survey instruments that are capable of capturing test takers that have different levels of ability of whatever trait it is you're trying to measure. And so Roche modeling, Roche measurement is one approach to doing that. And we mathematically, how that works is a relationship that works as follows. So this all banks on the idea that the log odds, or the odds of finding a respondent in a particular category, so agree, disagree, whatever, is based on that test taker's ability and the item difficulty. And so what happens is you solve this equation here for all of the different combinations of response categories, for all of the test takers, and for all of the items on your survey. You don't do that by hand. Obviously you use R to do that, right? And so I use a library in R called the test analysis module, which generates Roche models for each trial and each survey that we give. It also returns values of what we call person ability and item difficulty. So person ability, you could think of as like the amount of an underlying trait that a test taker has. We also use a tool called RightMap to make item person maps that plot person ability and item difficulty on the same logit scale, which makes for a nice comparison. Not going to go through any of these instrument parameters here in any details, but just say that they tell us that those survey instruments that I went through earlier are robust in their ability to differentiate between test takers of different ability and items of different difficulty levels. So that's good. Here's an example of an item person map or a right map. Persons are distributed here in these histograms. So folks up here at the top would have a very high level of a particular trait. And so in this case, Python skills. So these folks came into the program thinking that they had a high level of confidence in their ability to, perform different Python skills. Most of the folks, like earlier, came in with a low level of comfort. They didn't feel comfortable doing most of the Python skills that we asked them about. After the fact, you can see that the person distribution shifts upward, which is good. That's evidence that people are becoming more comfortable or confident with these different things. Finally, we use those measures of person ability as independent variables in an analysis of variance and then follow-up post-hoc t-testing. And so what this tells us is that trial, so pre and post, before and after, and dimension, so survey dimension, what dimension are we talking about? Python skills, data science skills, etc. Those two variables had a significant impact on the variation in person ability in these different categories. Not so much at the cohort level. So we don't see any significant difference between students from year 1 and year 2 when they come into the program, which is good. What we do see is that, significant growth overall in all of these different areas with science identity, demonstrating the lowest amount of growth, though still significant growth. All those values of Cohen's d are relatively are large values of Cohen's d, which is a measure of effect size, indicating that participating in the Earth Data Science Skill workshops has a large effect on students' Python skills, data science skills, etc. We can represent these findings visually too. So if we plot these things and look at how students' abilities grow from pre to post across the 5 dimensions, again, we see Python skills underwent the largest growth from pre to post. Science identity kind of saw the least amount of growth there. ANOVA tells us we don't need to split this up by cohort, but it's fun to make faceted figures in ggplot. And so here's what it looks like if you break this down by year 1 and year 2. Trends are largely the same. Okay, I've got about, it looks like 5 or 7 minutes or so maybe. Is that right? Before we're going to stop for questions? Sweet. Okay, thanks, Elizabeth. So I want to end with a brief conversation about another approach to learning and teaching Earth data science that we sponsor and lead here at the education team at Earth Lab. It's just called the Earth Data Analytics Foundations Professional Certificate, or EDA. The EDA is a 3-course sequence offered by Earth Lab through the Geography Department at CU. It's 3 courses. You can complete the program in 10 months. It's taught using Python. We also use GitHub Classroom. It's geared toward professionals, folks who are interested in changing careers, and science researchers. It's taught by our lead instructor, Elsa Culler. It's project-based learning with industry partners, and all of the course materials, textbooks, etc., are published as open educational resources on our earthdatascience.org website, which sees hundreds of thousands of visitors each month. So that's kind of a high-level overview of the Earth Data Analytics Professional Certificate. Like I said, it's a 3-course sequence. Start in the fall. Take the Earth Analytics Bootcamp, which here is what our Earth Data Science core is modeled after largely. And so we teach all of this stuff, but instead of doing it in 16 weeks, like Elsa does, we do it in 5. And we don't talk about loops and conditional statements, and we don't talk about functions because we don't have time, and that's more advanced stuff. The second course in the EDA certificate sequence is the Earth Analytics Online course. It's a little bit more advanced. Students apply what they learned in the fall, working with different types of spatial data, looking at how, applications of fire, flooding, etc. And then in the summer, they come back and they are working on a project with an industry partner. I don't have any examples of student projects that come out of the EDA program, but I can tell you that they're amazing. And unlike the Earth Data Science core, where students come in largely without any programming experience, here a lot of folks do come in having worked in R or worked in Python in the past, and so they can take things to a pretty high level. And if you've worked with any of the certificate students in the past, 1, thank you for the help. 2, I think you'll appreciate kind of the level that students are able to take some of these projects. So. Who is taking the Earth Data Analytics certificate courses? Well, since the program started back in 2017, we've had about 150 people complete the program. They're largely professional students, so they're completed an undergraduate degree and are not seeking any other degree, just trying to get their certificate. Although we do allow undergraduates to take the first 2 courses, and we do have some folks who are also working on graduate degrees. Kind of see how demographically we break down by age. Largely, students come to the EDA certificate program with geography and environmental science background. And we're pretty even split when we look at how things break down by gender. This is the last thing we're going to talk about. I know that I only have a couple minutes left. So like the assessment that we do in the Earth Data Science core, we also assess the students who complete the EDA certificate. So we ask them to complete lots of surveys, probably too many. But one item that we ask repeatedly throughout the course of the program is one that really gets at how students problem solve. And so we ask them this question at the beginning of the program, and we ask them this program somewhere in the middle of the program, and we ask them again at the end of the program. So we're not using that post-then pre-retrospective approach here. I'm sure you're wondering. This is a traditional pre-then post design. And so the question is, you're given 32 text files that contain daily temperature data for Boulder, Colorado over the last 32 years. They're stored in degrees Fahrenheit. Each text file contains 1 year's worth of data. You need to calculate the monthly average temperature in degrees Celsius for each year and then plot temperature over time. Your final plot will look similar to, and then we ask students, what tools would you use to solve this problem? Excel, scientific programming, Bash, other, and they can choose more than one here. And what we see is when they, at the beginning of the program, so what we're calling pre-boot camp, so before they've taken any of the courses, largely folks said, I would solve that problem using Excel. Like several said that they would use programming. Not very many thought that they would go to the command line and do anything with Bash or Shell. Fast forward to the end of the boot camp. Now we can see that overwhelmingly, in fact, everyone whose response we have recorded here, note this is only for the last 3 years too. So this does not go all the way back to the beginning of the program. It's just 2019 through 2021. Anyway, everyone who answered this said that they would use scientific programs. So all 60 people who we have before and after responses from to this item said they would use programming. Some said that they might clean up their data in Excel or do some pre-processing in Excel. Really impressed by the number of folks who said that they would go to the command line and do something involving bash or shell, particularly in this last cohort. So that's really impressive. And so big takeaway here, we're able to demonstrate that participating just in that boot camp course is having a big impact on how students approach problem solving, and they begin to think about that more programmatically. We ask them how comfortable they are using these tools. Not a ton of shift here. Generally, they're pretty comfortable with it. We have fewer students saying that they're very comfortable in the post-boot camp as compared to the pre-boot camp. And so that, I think, points to students maybe getting outside of their comfort zone a little bit, which is great. But we don't have anybody saying that they're very uncomfortable with it. Whereas prior to, we had, a few. So those are promising. And then the last thing that we ask them to do is we ask them to actually write it out. Like, how would you solve this? Step by step, tell me how you would do it. And you can see that, evidence of students thinking about doing it in Excel at the beginning of the program, talking about doing it in Python. Here, Devin is, kind of writing it out as a sentence, but then afterwards they're thinking, almost more like pseudocode. And then my favorite here is when we asked Kim, how would you do this? At the beginning of the program, Kim said, I'd copy and paste into an Excel and then make a chart. And then after, Kim said, all of this, I'd write a function in Python. From that, I would summarize the data by month. Usually I refer to example code. In this case, I would refer to either the final assignment or the time series homework. So it's like they're metacognitively kind of thinking about like how they would do this. Really interesting data. And I apologize for rushing through that so fast, but I think that the evidence is clear that both the Earth Data Science Core and the Earth Data Analytics programs are proven models. We've demonstrated that we're having an impact on how students problem solve, how comfortable they are with these different data science approaches. We've done all this online for the most part. So the first couple of years of the EDA certificate were done face-to-face, but for the last 3 years, we've all been online. We've learned a lot. We're working with underrepresented groups, particularly with the Earth Data Science Core. And I think having an impact on their comfort and their confidence is huge and goes a long way in that building capacity to learn and teach data science. Big takeaway is making your materials accessible to your students is key. So using things like Google Colab, putting your teaching materials up online, freely available is great. And I think project-based learning, using locally, culturally, and professionally relevant topics is key to helping students succeed in these situations. So finally, I would just add that we would love to collaborate with you. The education team would love to collaborate with you. Could we help you turn your research into curriculum somehow? Could we publish it on our open textbook? When you're filling out these proposals and you're asked about broader impact, maybe you would like some help from the education team in terms of seeing, how could you assess your program, or how could you impact a larger audience through educational outreach? And so we're here to help. I'd like to thank Leah and Jennifer, Lauren, Nathan, Elsa, Patty, and Anna at Series Education Outreach. Our faculty partners, Bill, if you're out there, thank you. Jenny Palomino, Sejad, and these are the works cited. So I will stop there and thank you for coming today. Thank you.
All right, do we have any questions, either in person or remote, to get us kicked off?
I have a brief request. I'd be really interested in adding some of that literature that you cited to my reading list. Do you mind putting up the that list again? I could take a screenshot or just like copy paste it, or super interesting.
Can you see that, Mike?
That's the one. Awesome.
Cool.
Thanks.
Happy to share. There's probably a ton more that didn't make it on there, but I was trying to cut down on space. And so, but yeah, let me know if any of that trips your trigger or want to talk more. Matt.
Yeah, so really nice talk. Thanks for sharing all this with us. A quick question. So you showed a lot of example with your assessments as kind of self-reporting assessments. Do you have any other kinds of assessments where you can actually look at how accurate folks' self-reporting is of their own kind of performances on some of these items?
Yeah, not really. You know, and there are certainly drawbacks to using, you know, assessment and survey instruments that rely on that self-reporting. I think in this case though, like I'm completely comfortable with that. Like far be it from me to tell one of these students like how confident or comfortable they are, I guess, is the way that I see it. And so no, we don't have any way of like testing to see like whether or not, you know, a student's reported shift in confidence went from, you know, not at all confident to majorly confident, other than looking at some of the artifacts that they turn in. And so their notebooks that they turn in every week and the projects that they work on, like I can tell you that starting at week 1, there's no way that I think that a lot of those students could have seen themselves doing that. And then, you know, 6 weeks later, now they're making these really cool maps. And so I think that is evidence that their confidence has gone up. But they don't really have to tell me that, but I can see it. So that's one way that I think about it.
Oh, Chelsea has a question.
Thanks, Nate. That was awesome. You showed a figure, I forget how it was worded exactly, but it was something like there was one figure that actually after the class that folks were less confident or less comfortable or something with some of the skills. And I think that's really interesting. And do you know which one I'm talking about? First of all, if we could go back, yeah.
Oh, it was one of those green bar charts, I think.
Yeah.
Way too many slides.
Oh no, it was towards the end.
It was towards the end, yeah.
Okay. So maybe it was, okay, yeah. Oh, I got you. So here we're looking at students who.
Yes. Yeah, it's this one.
Okay, cool. So yeah, these are students who take the
Yeah.
EDA certificate.
They're like overconfident in the beginning.
Yeah, exactly.
Yeah. I think this is one of those things, right? Where like, it's like, you don't know
Story of my
what you
life.
don't know until you get in there. Like, I could definitely see that. We're like, oh yeah, I know how to use this thing. And then you get in there and you're like, oh my gosh, there's so much more to learn, kind of a thing. I wonder if that's what's happening here.
I would not doubt that. What you're calling that is pre-test overestimation. And that's part of the reason that we do that post then pre-retrospective approach is because like you said, you might walk in and think like, oh yeah, dude, I'm totally good at making functions in Python. And then you get in there and you're like, what? And so, yeah, so this approach, which is what we do with the EDSC student, helps eliminate, we think, some of that pre-test overestimation. We're not doing that in the EDA certificate. And so that could be part of that. Is like you said, they walk in and they think, oh, I got this. Yep. And then they do it for 16 weeks and they're like, dude, that was hard. So yeah, great question.
Yeah, super interesting.
That actually, I have a question about the retrospective approach as well. Are there any like notable disadvantages to doing that? Essentially, it's like, why aren't people doing that all the time now instead of the classical model? Is it just because they don't like know about it, or are there like specific situations where it doesn't work?
Yeah, I did not know about it until I came here and worked with Patty. I don't know if Patty's still on the call or not, and Anna at Education and Outreach, and they said, hey, let's do this. And I was like, dude, that is a sweet approach. Why haven't I heard about that? And so I like it. So that's the reason that I wasn't using it, because I just didn't know that it was a thing. I guess one of the, I think like, I guess I'm sort of curious about like the asking students to think back 6 weeks to how you felt. You know, were they, you know, when I say, oh gosh, 6 weeks ago, I was only slightly confident. Like, is that necessarily true? I think there might be some, scenario where you might, have some questions about there, but otherwise I don't see any, disadvantages to doing it this way. And yeah, I would, if you're a social scientist or an educational researcher, I think this method works great, and I'd be happy to talk more about it to anybody that is interested in that kind of thing. And thank you, Patty, for turning me on to that idea. Mike, go ahead.
It's actually on this slide. Can you say a little bit more about response shift bias and sort of what that means, this sort of change in reference?
Yeah, so the idea is that I think the argument that they're trying to make there is you have a different frame of reference about a particular thing after having completed a course, right? And so you come into a course in Python 101, and you think you have some certain understanding of how Python works. And then 16 weeks later, you've had your whole mind changed in terms of what Python is, how it works, how you can apply it. And so your reference frame in respect to what you think Python is has changed in that regard. And so, and I think part of that too plays into this idea that when test takers are asked to complete this post-test, in some instances, they may bias their response to what they think the assessor wants to hear, in some sense. And so I may be confusing that with a different kind of bias here. But that is my understanding of how that response shift bias works. It's it's sort of like you're asking two different completely different thinkers to answer the same kind of question, 16 weeks later, because you've gone through the course, if that makes sense.
Interesting. So it's still related to the specific context of learning Python. It's not saying your frame of reference was whatever was going on externally in your life 16 weeks ago versus now. It's not necessarily related to that.
Yeah, I suppose that could have something to do with it too. I'm thinking more closely within the context of what Python is. But
interesting.
I think those external, variables could be at play here. I haven't spent enough time thinking about or reading about response shift bias myself. So I don't know that I have a really thoroughly thought out answer for that, but that's kind of my understanding.
Yeah, right on. Cool. Thanks for your thoughts.
No sweat. Anybody else?
We don't have any more in the room, and it looks like chat also doesn't have any. So we can probably wrap up now if you would like.
Totally. Yeah.
All right, thanks so much, Nate.
Thank you, everybody. Have a great day.
Thank you.
Thank you.